threads. What we're going to do now is start working with threads and learn how Java deals with threading. And I'm not talking about needle and thread, trying to sew. I'm talking about process threads and how applications execute. Well, if you're not exactly sure what a thread is, don't worry, I'm going to show you. That's the first thing we're going to talk about is threading, because creating separate threads for our programs to execute in makes them extremely efficient to run. Then we'll talk about the API about threading. Specifically, we'll take a look at the classes and interfaces that we're going to use when working with threads. So remember, now we've been working with classes for a while, and I've already taught you a little bit about interfaces. So we're going to start applying what we've learned about interfaces in this particular CBT nugget. Then I'm going to talk to you about a couple of critical methods that you use a lot with threading. Really, working with threads, I think, is for the most part fairly straightforward. It's just following the instructions, knowing the right classes, knowing the right interfaces, and the methods. Then finally, what we're going to do is we're going to create and work with threads, and then we're going to create our own little threading example there too. So let me start off with a nice explanation of what just exactly a thread is. Programs run in your computer. And what a program has to do is it has to execute and send commands to your CPU, and then your CPU interprets the commands and makes certain things on your computer happen to do things like, paint your monitor and access your hard drive. So these here represent your CPU. So this is like your little CPU here. This is your CPU. Now, in a world where we are single-threaded, we can only send one string or one stream of commands to the CPU. And you'll notice that they just kind of follow each other and they execute in a linear order. So this here would be considered a string of commands. This green line here, let's say this green line was, download something. So from here to here, I'm downloading. And then this red line here, this next red line here, let's say this was copy something, okay? And this blue one here is to calculate something. This purple one here is to move a file, etc. So basically, this will execute first because it is right by the processor. Then, in order for me to calculate something, I have to wait for this thread to execute. Then this one can happen. Then that finishes. Then I do the next one here, then this one and this one. It would be like having, if everything was single-threaded, it would be like having to wait for a file to download before you could do something else. But that's just not how it works. We are able to multitask on a computer. Now, the reality of it is we're not really multitasking because we only have one CPU. And you see, a CPU can only do one thing at a time. It can only do one command at a time. It does that one thing at a time extremely fast, right? CPUs are rated in MIPS, millions of instructions per second. But with the advent of processing architectures in Windows 95, we started to move in quote-unquote a multi-threaded environment. And what's happening there is we are able, instead of waiting in line for things to execute, we are able to send multiple things to the processor. And it happens what appears to be simultaneous. Now, in reality, what's happening is there's a part of the operating system called the microkernel or the scheduler, which basically says, okay, you're going to run for a second, then you, then you, then you, now you back here. And it's basically doing what's like multiplexing, okay? And each one of these threads is assigned a priority. And the higher the priority, or the lower the priority, determines the order on which your thread will run. However, we still have the effect of completely, what would appear at least, to be multitasking. And again, things happen on the computer so fast that, for our brain at the speed we run, it does appear to be multitasking. Now, here's something that you really have to get clear. We have absolutely no control in Java of when our application will run. We do not. You see, the main method, that main method that we've been using for a while, is the main thread. All of the programs we've been writing up until this point have been single-threaded. They all run in main. which is the main primary thread that starts a Java application. But when we start a Java application, it goes to the operating system's microkernel or scheduler. Just so you know, a microkernel is a Windows term and scheduler is kind of more generic. And it's up to the process, it's up to that component of the operating system to go ahead and permit the thread to execute and hit the processor. So basically, every time we run a Java application, we're kind of suggesting to the operating system, hey, you know what? We're available to run. Run us whenever you want. And you'll notice that, we tend to get run, but sometimes it's not as instant as other times. And that's again because of what's going on with the scheduler and the operating system. Now, working with threads is an extremely flexible process. We have several ways about doing it. And sometimes one way will make better sense than the next way. So let's start digging into the syntax and building some multi-threaded applications. We're going to start by digging into the Java API. So let's bring up our good old buddy, the Java website. And you can see here I'm at the java.sun.com/Java2 Standard Edition, the version docs API. All right. I'm in the java.lang package again. We haven't gone into too much detail about packages yet, but we will eventually. So just know that packages allow me, or allow Java, Sun actually, to organize their classes into groups of logical common functionality. And I did say allow me, and it's true because eventually we'll be creating our own packages. And there's two very important classes, or I should say one class and one interface. The thread class. Now, I went into a nice detailed explanation of what a thread is, how you can send multiple streams of execution to the CPU. In actuality, okay, a thread is an instance of the java.lang.thread class. All Java threads start some way, shape, or form as an instance of the java.lang thread class. And its ultimate technical, explanation. A thread is a Java object. You can see public class thread, extends object, and what is this? Look at implements, which means it uses the runnable interface. And runnable is the interface that we'll talk about here in a little bit. So you can read up on the threads, but I want to point out a couple of different methods to you that are typically found in the thread class. First, let's take a look at the constructors. How do you create a thread? Well, you can just use an empty constructor. You can pass runnable targets to it. You can give it a name by passing a string. And you can even work with groups of threads called thread group classes or thread group objects. The methods. We have active count, gives us the number of threads. We have count stack frames, the current thread. But let's run down and take a look at a really important one called the run method. The run method is probably one of the most important methods that you will use working with threads. If this thread was constructed using a separate runnable object, the runnable object's run method is called. Otherwise, this method does nothing and returns. The run method is something that we will override in our threads. Now, when I say in our threads, I mean in the classes we create that somehow either are derived from thread or implement runnable. And essentially what we're going to do is the code that needs to run in its own separate thread, that is going to be placed in the run method. And that run method will call other methods. And the thread execution of a new call stack always begins by invoking run. So that's what thread is. Two things, essentially in Java. It's either creating a class that inherits or extends from java.lang.thread, or it's a class that implements runnable. So now that we've kind of tried that, let's go ahead and take a look at some basic examples. Let's go ahead and do an example of working with threads that will start off kind of easy and work our way into more complicated examples. So I'm going to create a class, and it would look something like this. So I'll say public or class, and we'll call it thread demo 1 or 1. And here's what we do. It extends thread. And again, as I said, a thread is just some way, shape, or form an instance of the thread class. And by creating your own class that extends thread, thread demo 1 is now a thread. And then what we want to do is go ahead and override the run method. So we'll say public void run, okay? And then essentially the code that goes in there is what we'll isolate into a separate thread. So code to run in a separate thread, okay? That's how it works. So this code, whenever I create an instance of thread demo 1, and I want the code to run in a separate thread, anything in its run method will go ahead and isolate as a separate thread. Now, that's one way of doing it, but there's a problem with creating threads this way. And the problem is right up here. I've gone ahead and used up the one chance I have to use implementation inheritance, right? Because a class cannot inherit from more than one class. So if I say extends here, I'm done. So the next thing that I can do, instead of inheriting from the thread class, is I can go ahead and implement the runnable class, or the runnable interface rather. So let's take a look at that. It's fairly simple. I'm going to still override the run method. Okay, so I'm going to leave public void run in there, but instead of saying extends thread, I'm going to say, whoops, got a little too overzealous with the backspace key there. I'm going to say implements runnable. And this is definitely the preferred way of doing it, by implementing the runnable interface. To see the power of multi-threaded applications, let's take a look at an example of using a single-threaded application. Now, I created a class called GenerateNumbers, which is basically going to be used to print out numbers. Here I've got a GenerateNumbers constructor that takes two parameters, two integers, st, which will set your start, and inc, which will set your incrementer. So if you pass in a number like 1 and 2, what will happen is 1 will come in as your start, so I equals 1, and 2 comes in as your incrementer. So you'll see that here what's going to happen, I equals 1, we've set j equal to 0, we're going to just increment j plus 1, and then we're going to take our incrementer and set it to I. So I is 1, then it's 3, then it's 5. So basically, if you pass 1 and 2 here, it will be odd. If you pass 2 and 2 here, it'll be even, because what will happen is I will be 2, and you'll be plus equaling it, or reassigning and adding by 2. So it'll be 2, 4, 6, 8, etc. Don't worry about the logic of it, but you'll see it's going to print out numbers, either odd or even, depending on how I start and what I specify is the incrementer. Here's where the real lack of power comes in, I should say. You see, I instantiate two instances of it. The top one to print out odds, and the bottom one to print out even. Now, I've got my own print method here that I've gone ahead and used. Now, here's why you're going to see it's single-threaded. It's single-threaded because this is going to run and execute complete. It's going to start and stop. And then this one. There is no chance of having a mix-up, because I'm not sending each instance to the processor simultaneously to be run as its own thread. This whole main method will be run as one single thread. So first this, then this. Now I've already compiled it, so let me go ahead and clear this, and let's go ahead and run it again. So I'll say Java no threads. Let's see what we get. Take a few seconds to think, and here we go. You see, it's going to do 1, 3, 5, 7. In other words, all of the odd numbers are going to happen first. Then what's going to happen is all of the evens, because it's single-threaded. So the first method call happens first, and the second call happens second. So now what I'd like to do is actually go ahead and start making this into a multi-threaded application, and we'll start seeing how this is going to behave. The first way I'm going to convert this into a multi-threaded application is we're going to do it the simple way. So I'm just going to take my GenerateNumbers class, and I'm going to extend the thread class. So basically, I've now converted my GenerateNumbers class into a thread by inheriting from it. Remember, inheritance is a relationship. Now, I've already got this print method defined. So I don't need to really rewrite that. I could just simply go ahead and make this the run method. Okay, but I'd like to show you a little bit more advanced way of thinking just to expand your mind a little bit about programming, because as I said earlier, the run method contains all the code that is to run in a single thread. Okay, or I should say in its own thread. Now, I've already got this coded, so how do I make the run method execute this stuff? I simply go ahead and call my print method, so print. Okay, so there we have it. Now what I'm going to do is I'm going to instantiate two instances of the class. Now what we have to remember is I've already done it, and generate numbers is a thread. You got to understand it. It is a thread because it's inheriting from threads. Now it's a specialized thread. It's basically used for counting. Now here's what I'm going to show you first. So I'm going to call run, and then I'm going to call run. Okay, so I'm going to go ahead and compile it, do a control 1. And now I'm going to go ahead and run it by doing a control 2. Okay, here's the huge deal. By calling the run method, you do not launch it in its separate thread. Notice how first I have my odds, then I have my evens. Well, that's basically what we had before. Matter of fact, let me go ahead and bring up a command prompt because I'm going to want to have that. All right, let's minimize you. Instead, what we do is we call another special method. I already taught you about the run method. This contains the code that is to run in its own thread. Any job you want done goes in the run method. But to launch a thread, actually, technically speaking, to start a thread, which means I'm going to suggest to my computer's operating system, to its scheduler, to its microkernel, I'm going to say, look, go ahead and whenever you have a chance, please run this. So let me go ahead and compile. All right, now I'm going to run it. Let's see what we get. So I say Java, no threads. You know, I just realized I should have renamed the class to threads. But you see what I say. Look it, I can already see the intermingling of even and odd numbers. Here we have 1, 3, 5, 7, 9, 2, 4, 6, 8. So you could see that the even number, rather the odd number one ran for a little bit first. Then the scheduler said, okay, now even one run for a little while. Then it said, okay, odd version run for a little while, and so on. Let's go ahead and clear this and run it again. No threads. See what we get. Okay, you can see here it's doing the same thing. Here, odd one starts, then the even one. Okay. And now the results aren't going to always be as predictable as this. It's really important that you understand that. We really have no idea which thread is going to execute first. It's all really depends on the operating system. But now we could see in how the even and odd numbers are intermingled, because what's happening is we're sending each one of these to the processor simultaneously, and we're letting the operating system say even one run for a little bit, then the odd one, then back and forth, and we're letting the computer schedule that. Now let's go ahead and show you how to do this by implementing the runnable interface. All right, the first thing I'm going to do is I'm going to just do a quick save as, because I want to rename this file to runnable demo.java. And I'm going to rename the class to runnable demo here. Runnable demo. All right, now this class is fairly easy to work with. We essentially changed this to, instead of extends threads, to implements runnable. Okay, that's a fairly straightforward process. Here's where things get a little bit different up here. Instead of creating instances of the generate numbers class, I can no longer do that because generate numbers is no longer a thread. So what I have to do is, let me go ahead and show you here. Let's space this down, and I'm going to say thread. Let's do it this way. because I'm going to keep the two instances that I have. So I essentially created those two instances, and I create a thread T1, that's my first thread, and it's going to equal a new thread, and what I get to pass to it is an object that I want to run in its own thread, okay? And then thread 2, or T2, is a new thread, okay? And I pass into it the second object that I want to run in its own thread. Now I do a T1.start and a T2.start, all right? And I go ahead and compile. And I'll do a control 2 and we'll run it. And here you can see we have the nice intermingling of here's our odds, little even, a little odd, and we get back to the evens. We essentially get the same result, okay? And that's what's going on with threads. Now what I'd like to do is kind of give you a real cool example of using threads using Java Swing classes. Let's take a look at the simple Swing application that I wrote. Notice how I imported the appropriate packages, java.awt, javax.swing. Now, I created a Swing demo class that is in itself a JFrame. I extended or inherited from JFrame. My constructor, I created a constructor where I set the title, the size, and show. Then I have my own main method in which I go ahead and instantiate an instance of my own self, if you will, or my own JFrame. So I go ahead and do a control 2 to run it, and here we can see I get my mainframe, my JFrame rather, not my mainframe, but my JFrame. Now, what I want to do with you is I want to create a digital clock that runs right in there, okay? So let's go ahead and close this out. Now, remember, we haven't gone over event handling, so we're not ready to go ahead and employ that within our class, within our JFrame. All right, so I went ahead and modified the original swingdemo.java file. Here I added two more packages because I'm going to use the java.util.date class and the java.text.date format class that we already talked about a while back ago. Don't worry about anything going on up there yet. Let's take a look and see what I did. I created a class down below this, this class that you already saw, the Swing demo class, and it's called Digital Clock. And what I did was I extended JLabel and implemented Runnable, which means I'm inheriting from JLabel and I am using the Runnable interface, which another way of saying that is my digital clock class is a JLabel that is runnable. So what does this give me? Well, let's take a look at the void run method first. Public void run. Now you'll notice that I have a try catch block. What I'm hoping is that you'll see is that everything I've taught you earlier is not going to go away. These separate little CBT Nugget videos that you're watching aren't mutually exclusive. You don't watch one and forget about it when you go on to the second one, then forget about that when you go on to the third one. This whole course builds on top of it. So look at, here's a try catch block that we have to implement, and I'll show you why we have to do it. Now, what I did was I created an infinite loop. I used a while loop, talked about that a long time ago, and I just put true in there, which means this loop will run at infinitum. I created a new instance of the date class called the time. And what I did was I took the date format dot get time instance. Before we used the get date time instance. And there's also a get date, but I'm specifically interested in the time, so I called the get time instance, and I formatted it as long, which will give me hour, minutes, and seconds. Then what I did was I called set text. Now remember, I am, or I should say, this digital clock is a JLabel. And therefore, when I'm calling the set text method here, I'm calling the set text method of myself, which means I'm setting the text of the JLabel I'm going to be. And what am I setting the text to? I'm calling the date format method, and I'm specifying my date class, my date object in there called the time. Then I'm calling something thread.sleep. Now, we haven't talked about this yet, but threads are in different states. They're either running, they're waiting, or they're sleeping. And what you can do is you could suggest to the scheduler of the operating system, you'll say, look, run this thread for 1,000 milliseconds, then let it go to sleep for 1,000 milliseconds, and then run it again every 1,000 milliseconds. And if you don't know, 1,000 milliseconds is 1 second. So basically, what I'm doing every second is I'm creating a new instance of the time class, and I am going ahead and I'm formatting it, and I'm setting the text of a label, and I'm doing it every 1,000 seconds. Now, thread.sleep, if we look it up in the Java API, just trust me on this, throws the interrupted exception. So I'm going to be catching that. And if that interrupted exception occurs, I'm going to be assigning the text of my JLabel the message. I'm going to call the get message of the interrupted exception, which is just the official text of the message. Now, the constructor. This is where things get a little complicated. What I'm doing in the constructor is when you create a new instance of the digital clock class, this is where I'm going to create the thread. Now, this keyword here, we talked about it before when we were working with constructors. But in this context, what it means is when you create an instance of the digital clock class, pass this own instance into the thread and then call the start method. All right, let's take a look at this in action up in the top and how we're going to implement it. All right, so here's the Swing demo class, and notice all I have to do is create a new instance of the digital clock class, and I call the get content pane to give me the container that allows me to call the add method, and I'm going to put my digital clock up to the border layout north. So what I've done here is in this digital clock class is I've encapsulated all of this functionality. And now anytime I need a digital clock, I just go ahead and instantiate an instance of it and put it into a JFrame. So I'm going to hit Control 2 here, and let's build this, or let's get this JFrame running and see what we get. Check it out. Here we go. Do you notice how it's moving? The timer is ticking and ticking, and this clock runs in its own thread. And that's why I'm able to have it just continuously run and go ahead and update the time. And we'll reuse this component later on, and you'll see that because it's running in its own thread, I'll be able to do other things. You'll notice that it doesn't really affect, if I'm resizing this here, you can see the clock is still ticking. Now, sometimes you'll see that it's slower. And sometimes what you can do is kind of speed up your mouse a little bit and get the processor running. And did you see how it skipped to 2? If I let me move my mouse around and around and around. Notice how it's still holding on to 2. I stop and boom, it jumped to 18. Why did that happen? Because, and I did that to demonstrate a very critical factor. As I said earlier, we have no control of when our threads run. All we do is we suggest to the operating system to run the thread or to pause it for 1,000 milliseconds. But if the operating system is busy with higher priority threads than our lower priority threads, they just wait until there's room for us to run. That's an important thing. For example, have you ever noticed that when your computer crashes, your mouse still works? Well, because the mouse, the code that executes the mouse, it runs at an extremely high priority, almost at the priority of the operating system, because Microsoft says, well, we're a mouse-driven operating system, and if there's ever a crash, that mouse needs to work. Now, and you know that when your mouse freezes, you basically have to just do the old, reboot the computer kind of a thing. The same principle applies here. In Threads, we took a look at how Java allows us to do multi-threaded applications. We defined what a thread is, how it allows us to send several requests to a processor at one time, so we could do things like run a digital clock and download a program at the same time. We took a look at the classes and interfaces used with working with threads, namely the thread class and the runnable interface. And we took a look at two important methods. The run method contains all the code that will run in its own thread. The start method is used to start the thread, or I should be more correctly in saying it suggests to the CPU, or rather it suggests to the operating system, hey, go ahead and start. Then we did a couple of different examples with threads. First, I created you a non-threaded application with those even and odd numbers, how it first ran the odds, then the even. Then I started doing some different things with threads, and you saw how it ran a little odd, then a little even, then a little odd, and then I gave you kind of a real-world application on creating a GUI application using a digital clock. I hope you have found this informative, and I'd like to thank you for viewing.